Chapter 4, Section 4, the right triangle. This is actually a very simple section because we've studied so much in the previous sections that we can now apply that to what we call the right triangle. So, to solve a right triangle, this actually means that when we are given three parts of a triangle, we got to have at least one side. Then we are able to find the other three parts. Now, to do this, we need to have some sort of consistency. Therefore, we're always going to label our right triangle as follows. So, our angles are capital A, capital B, capital C, with C being the right angle. And then our sides are going to be a, lowercase b, and lowercase c. The most important part about this, all right, is that these two match, all right? The right angle will always be opposite the hypotenuse. Otherwise, none of this is going to be right. So here's a really, really easy example. So what I want to do is solve the right triangle with angle A equal to 30 degrees and side B equal to 3. All right. So once again, here's what we're going to do. We're going to draw a right triangle, keep it nice and consistent. We know this angle on the inside, 30 degrees, and we also know B is 3. Now, we're going to find A, C, angle B, and angle C. All right? So when we look at this, we already know angle A is equal to 30. And like I said, we already know side B is 3. Now the question becomes, well, how do we get all the other stuff? Easiest thing, get the right angle first. So in purple, C is going to equal 90 degrees. Now, if this is 90 degrees, and we know that angle in the lower left-hand corner is 30, then this angle right here, angle B, has to be 180 minus 90 plus 30, or angle B has to equal 180 minus 120, so angle B is 60 degrees. So we got all of our angles done. Now the question becomes, how do we find our sides? Well, when you look at this, all right, and let me redraw this right triangle. When you look at this, the only thing we know is this side opposite of our angle theta is 3. We don't know A or C, therefore the Pythagorean theorem doesn't help us here. However, we do know our ratios of all of our trig identities. So, if you look at what we have here, all right, if you look at what we have here, we have all the information we need. For example, we know angle A is 30. So why not just use one of my trig identities? The one I'm going to choose is tangent. Tangent is one of the best ones. So we know tangent theta is opposite over adjacent. Okay? So in this case, it's going to be tangent of 30 equals 3 over the letter A. So now from here, I can solve this by multiplying both sides by the letter A. Let's multiply both sides by A. That's going to give me A tangent theta, or in this case, A tangent 30 equals 3. And then divide both sides by the tangent of 30. To give me the following. Side A equals 3 over the tangent of 30. Now, since that is a measurement in degrees, just make sure your calculator is in degrees. And we're just going to go ahead and type this in. So, 3 divided by the tangent of 30. Oops, lost my calculator. 3 divided by the tangent of 30 is 5.19. So there's what side A is. Now that we have A, which is approximately 5.19 to 2 decimal places, we can go ahead and we can find C, and you could do this multiple ways. You have A, you have B, you can find C by using the Pythagorean theorem. However, here's the issue with this, and this is going to be like my little note. Be careful using calculated values. All right, and the reason for that, if this number is wrong and you try to use that value within the Pythagorean theorem, C is automatically going to be wrong. So always try to use original numbers or original values, like whatever the problem says. All right, so for us, real quick, I'm going to do it 2 ways. We're going to find C. So if I want to, I can use the Pythagorean theorem, even though I just said be careful. I'm telling you, just be careful. You can use it, but you better make sure you're correct. And the only way to really verify that you're correct is by doing it 2 different ways. So if we use the Pythagorean theorem, basically what we're going to have is the square root of 5.19 squared plus 3 squared equals C. And when you go ahead and you type that into your calculator, you're going to end up getting 5.995, which is approximately C. And if you think about this, I would probably just round that to 6. Okay? The foolproof way is to do it like this. We know this angle was 30 degrees. We know this was 3. We're trying to find C. Well, remember, if you're standing at the angle, right, if theta is down here where you are standing, this is opposite over hypotenuse. Opposite over hypotenuse. If you remember, that is sine. So, sine of 30 equals 3 over C. So I just multiply both sides by C. And finally, divide both sides by the sine of 30. So C is going to equal 3 over the sine of 30. And when you type that into your calculator, let's go ahead, let's do that together. Let me get out my calculator. Turn it on. 3 divided by the sine of 30 equals 6. So C equals 6. So you can clearly see the difference here in methods. If I use an approximated number, I'm going to get an approximated answer. If I use exact values from the problem, I get exact answers, which is exactly what I wanted. Okay? Let's do one more example, because this one I gave you a side and an angle, okay? Actually, I gave you side, angle, angle. For our next example, we're going to find all the missing values for the following. So we don't know any of our angles, A, B, or C, nor do we know lowercase side b, all right? But when you really take a step back and you think about it, it's a right triangle. Easiest thing we can find is our right angle. So we know C equals 90 degrees. That's easy. The next easiest thing to find would be side B, because all we have to do is use the Pythagorean theorem. So if I use the Pythagorean theorem, here's what I have. I have 51.38 squared plus b squared equals 74.12 squared. Now, hopefully you can see it from here, but this equation just basically turns out to be this. B equals the square root of 74.12 squared minus 51.38 squared. So I'm going to do this off camera, but I'm going to go ahead, pause the video, type this into my calculator, and we're going to get B equal to, I came up with 53.42. All right, so now we have side B. In fact, you know what? I'm going to start just filling this stuff out. So that's 90 degrees. And then we have 53.42. Now the question becomes, how do we find these angles? And remember, we want to stick with the numbers that the problem provided for us. All right, so here's like a nice little thing you can do. First, you're just going to draw theta. Now, if we look at theta, theta is adjacent to 51.38, which was given to us, and the opposite side is 74.12, also a value given to us. So if you think about that, that is adjacent over hypotenuse. That is cosine. So cosine of theta is going to equal adjacent 51.38 over 74.12. Now, remember, to find an angle, you use the inverse trig functions. So, cosine inverse of 51.38 over 74.12 is going to equal theta. So, theta equals, and I'm going to do this off screen on my calculator. I came up with 46.12 degrees. So far in our right triangle, I'm going to scroll back up. I'm going to write it in purple. Theta is 46.12. All right. And now you can actually find what angle B is. All right. And you could do this, once again, two ways. The first way, the way you got to be careful, we know the interior angles have to add up to 180. So B is going to equal 180 minus 90 plus 46.12. But just remember, since we're using an approximated value, we're going to get an approximated answer. So whenever you do this, angle B is going to be equal to 43.88. All right, so that's what angle B is. The other way to think about this, all right, is like this. Let me redraw this for us. Actually, I'm just going to copy and paste. All right, so check this out. In the previous example, in the lower left-hand corner for angle A, I said that was theta. So we said, okay, well, theta is going to be adjacent over hypotenuse. But remember in the previous video where we were talking about the trig functions and we said, hey, this works for all right triangles. So here's what I'm going to do. Watch this. I'm just going to rewrite 46.12. I am now going to put theta up here. See, I transitioned my theta to the upper right-hand corner. But now, if I'm standing here in this corner, that is opposite, that is hypotenuse. So my perspective changed a little bit. So opposite over hypotenuse, well, this will be sine theta is going to equal 51.38 over 74.12. Using the inverse trig law, the inverse sine of 51.38 over 74.12 should equal theta. Now, if you look up above, we got angle B to be 43.88. So I'm going to use our calculator on screen so you can see this. And if it ever turns on, there we go. All right, so here we go. You ready? Inverse sine 51.38 divided by 74.12. And look what you get. 43.8839 and all those other decimal places. Or theta is approximately 43.88, which we can change theta into B now. And that's exactly what we were looking for. So this section is just all about taking everything that we learned and just applying it to all these different types of situations. That's going to be it for this video, and I'll see you in the next one.